Hello everyone, welcome to the next video of our CN course, and in this video we are going to discuss about the TCP IP Protocol Suite. Like in our last video we discussed that there is an OSI model and we discussed about the different layers which are present in the OSI model, and we also saw the functions of those different layers. Right now in this video we will be discussing about the TCP IP Protocol Suite and how it is different from the OSI model. So let's start with the TCP IP Protocol Suite. Basically, this TCP IP Protocol Suite, this is an practical approach of designing and understanding the network architecture, while OSI model was the theoretical approach. Right, the OSI model, it was like a theoretical model. It was discovered by ISO and this was introduced by the ARPANET. Like these things have already been discussed with the web hub. I hope you people must have covered those videos, so I'm not going into much detail about these things. So yeah, this is the very main difference about the TCP and IP Protocol Suite and OSI model. Now one more difference is that, like the OSI model, like I told you, that this is a layered, it is having a layered framework, while TCP IP is also having a layered framework. This is a similarity between these two things, right? But the difference is in the OSI model, like we saw, there are 7 different layers, right? In TCP IP, we have either 4 different layers or 5. Like in some books, it is mentioned that there are 4 different layers, while some books take it as 5 different layers. In our course, we will be taking as 5 different layers, right? So yeah, this is the main difference between TCP IP Protocol Suite and OSI model. One more thing, the TCP IP Protocol Suite, this is sort of, it gives the flexibility between the different layers. Here also the different layers are interconnected, but there is a flexibility between the functions of different layers, while in OSI model, there is a rigidness, right? So this is the main difference between the OSI model and TCP IP Protocol Suite. Now if we discuss about the different layers of the TCP IP Protocol Suite, we can understand this through this diagram. The OSI model has these different layers, right? Like we already discussed that they are these 7 different layers through which basically the data is sent from one system to the other. Right now in the TCP IP Protocol Suite, there are 5 different layers. The only difference is that these 3 different layers have been merged as one in the TCP IP Protocol Suite. Right here, like practically we don't differentiate between the functions of these 3 different layers, right? Practically, like only application layer can perform the functions of these 3 different layers. So here in the TCP IP Protocol Suite, we have this layer as the one common layer for all these 3 functions, for all the functions of these 3 layers, and then we have these 4 layers which are similar to the OSI model only, right? Now, like the functions are they are very much similar to the OSI model only. So like there's no such difference between the functions of these different layers. Like we can understand this through an example. Like I hope you people must have covered the videos of OSI model, which I just discussed prior to the TCP IP Protocol Suite. So the functions have been discussed in those videos, so I won't be repeating it again here. We will be seeing it through an example only. So let's say there is a private internet and the data is being sent from A to B. Like the data is to be sent from A to B. A and B are 2 different systems. Now firstly, as we saw in the OSI model as well, in the physical layer the data is received in the form of signals and it converts the data in the form of simple bits, right? So here, as you can people also see in this diagram, the data is converted the signals are converted in the form of bits, in the form of stream of bits. So here in the physical layer, the data is sent in the form of bits, right? And these are the different links through which the data is being sent from A to B, right? These links are considered as different entities here, right? Now in the data link layer, we have as in the OSI model, we discussed that the stream of bits are converted into the frames for better understanding, or for the better understanding of the receiver. The stream of bits are converted into the frames. So here you can see that those stream of bits are converted into the frames, and one header is added, and this header contains the physical addresses of the receiver and the sender. Like we will be discussing what do we mean by the physical addresses in the next videos. So for now, you people can understand that here the stream of bits are converted into the frames, and it also contains the physical addresses of the sender and receiver, right? Here also the data is being sent uh, through different links. Now next comes the network layer, right? In the network layer, as we discussed in the OSI model as well, the routing is done, like the route for which the data will follow from A to B is set here, and also it adds the logical addresses to the header of the this datagram, right? Here as you can see, the from frame, the unit of data which is being sent has been converted to the datagram. In network layer we call it as datagram. Here in logical addresses, like I already discussed, that IP addresses of the sender and receiver are added, and here complete source to destination kind of delivery is done. Here there are no links. Here the datagram is sent from source to destination, and like it can be sent through different routers if they are not present in the same network. If had the data being sent in the if we have to send the data in the same network, then we don't need different routers for that. We can send the data directly. But here, as they both are not present in the same network, so different routers are used for that, right? Now next we have is transport layer. In the transport layer, basically the datagrams are converted into the segments. Like in network layer, each data packet is considered as an there are individual packets, and those are considered as uh, as messages, right? Now while in transport layer, if there is a message and it contains 10 data packets, then it is concerned with all these 10 packets, right? It here the individual packets does not contain, they are not considered as different. Here in transport layer, they are considered as one only, right? So it basically deals with the error control and flow control of the data segments, right? Error control, basically it means that it checks if the data is not corrupted or missing or is not duplicated, right? And with the flow control, it checks if the flow between the sender and receiver is constant or not, right? So this is about the transport layer, and here the port addresses are also added, and here from the datagram, the unit is changed to segment or packet, right? Now similar to OSI model, this is also a process to process delivery. Now next we have is application layer, right? Here in the application layer, in the TCP IP model, the functions of all three different layers, presentation, session, and application layer, are done in the one application layer. Like here the like data translation, data encryption, compression, or like connection establishment, connection maintenance, all these things are done in the application layer only, right? So this is like closest to the end user, and here the unit is the message, right? So these are the main functions of the different layers of TCP IP protocol suite. Like you people must have realized it till now that the functions are similar to the OSI model only, but the only difference here is that all these three layers have been merged as one single layer only. So yeah, that's the main uh, main difference between OSI and application layer. So that's all about TCP IP protocol suite. Now, next we will be discussing about the addressing part. See you in the next video.